Hello everyone, welcome to your first Algebra 2 video. This video is on section 2.3, composition of functions. Okay, so if you flip to that page in your flip book, we will start on the left hand side of your notes. So composition comes from the word composed, which if you are at all familiar with that word, it means made up of, right? Okay, so there are a couple ways to show that functions are being composed of each other, and the most popular way is with parentheses. And the two most popular letters used to represent functions are F and G, but they could use different letters, like H. I've seen H before, but usually F, G, and H are the three most popular. So they could use parentheses to show a composition of two functions. They could also use this little symbol, and it's an open circle in between the two functions that you are composing. So it looks like it spells the word fog, but really that open circle is supposed to be a little smaller as it is over here. And then usually parentheses are around it, and then they tell you which variable that they are using for those two functions, and it is usually x. Could be a different letter, but it's usually x. So those are the two ways that you will see compositions of functions written. So now we're going to talk about what it means to compose two functions. So when you are composing two functions, you are basically going to make the output of one function the input of another. Bear with me, my handwriting is terrible on here. Hopefully it will get better as the year goes on. So to do this, you are always going to start. This might seem funny for one of the ways. For the first way, with the parentheses, it should make sense that you start with the innermost function. Okay, when we work with parentheses, we usually start with the very inside. So you're going to always start with the innermost if it's written in the parentheses form. Okay, so if it's in the parentheses, you're starting with the innermost. If it's written the second way with the composition symbol, you're going to start at the end with the function that's written second or last on the far right. Okay? So you're starting with the innermost or the far right, depending on which way your composition is written. And then the one thing you have to be careful of is that F composed or made up of G is not always the same as G composed of F. Now, it's usually that they're not always, like 99% of the time, they're not the same. There is that rare case where, and it might just happen by coincidence, where when you plug in, if you do F composed of G, you will get the same answer as G composed of F. But that is just a fluke thing. There is usually no reason why that happens. So don't think that it will always happen, because it in fact will rarely happen. Okay, so let's do some examples. You'll notice over here they all say A. For some reason the formatting got messed up, but obviously that should be A, B, C, D, E. So we're going to start with A, the actual first one. And these are the two functions we're using for the first three examples. We're using this function for F. We're using x squared minus 5, and for G we're using 2x plus 3. So here's what this first one says. It says, figure out what F composed of or made up of G of 1 is. So what you're going to do is you're going to start on the inside, and you're going to figure out what is G of 1. So I'm going to do a little scratch work up here. Some of you can do it in your head, but G of 1 means you're going to take 1 and plug it in, that is the input, into G. So I'm going to plug that in for x into my g of x function. So I'm going to have 2 times 1. And you'll notice I do this all the time, and you should get in this habit. When you are putting a number in for a variable, you should put it in parentheses. There's many reasons why, but the biggest reason is that if it happens to be a negative number, sometimes some funny stuff will happen, especially if we have exponents, if we forget to put our parentheses around it. So just get in that habit now. Put parentheses around any inputs you plug in for a variable. So this turns out to be 5. Now, that should be something you've done before. You've plugged in inputs, numbers for x, and figured out what you get. Well, here's the new step. Now you're going to take that output. You're going to take the 5, and he becomes the input for the second function. So you're not finding f of 1. You're finding f of whatever g of 1 turned out to be, and g of 1 turned out to be 5. So now we're going to find f of 5. So I'm going to plug in 5 into my function f. So that's 5 squared minus 5, which is 25 minus 5, which is 20. So my final answer for this question is 20. So we took the output of the first function and it became the input of the second function. Okay, so the second example is written the other way with the little composition symbol. So this is g made up of f of 3. So in the parentheses it tells you what your first input is going to be. So first you remember you always start with the far right and you work backwards. So you're going to start with f. So we're finding f of 3. F of 3, I'm going to plug in 3 to f. So that's 3 squared. And I forgot to put parentheses around my 5 up here. I told you to always do that, and then I forgot to do it. 3 squared minus 5, which is 9 minus 5, which is 4. Now 4, the output, becomes the input of the second function, which is actually g. Even though it's listed first, it's actually the second function. So I'm going to do g of 4 now to find my final answer. So I'm going to plug in 4 to g. So that's 2 times 4 plus 3, which is 15. So 15 is your final answer for that question. All right, the last one's kind of weird because there is no number to plug in for your input. They said just leave it as x. Figure out what g made up of f of x is. So I'm going to write it like I was up here, even though there's no number. So first I would do the innermost, which is f of x. Well, f of x is simply x squared minus 5. Now that's my output for f of x, so I'm going to take my output and it becomes the input of g. So now I'm going to find out what g of x squared minus 5 is. So all I'm doing here is replacing my x, my input, in g with my output from f. Well, my output was x squared minus 5. So again, put it in parentheses. So you're going to have 2 times x squared minus 5 plus 3. And that's your answer. We do need to simplify this though, because we can distribute the 2 and then combine our like terms. So we would get 2x squared minus 10 plus 3. And then minus 10 plus 3, so that's 2x squared minus 7. That's your final answer. So it gets a little tricky when they have your first input be a letter, like x, but all you do is you plug in whatever they tell you to plug in, and it happens to be x, but we already know what that is. F of x was x squared minus 5. And then we take that output, and it becomes our new input into the second function. All right, the last 2 examples deal with working with graphs. Pay attention, it's written very small, you can't really see it, but this graph is our f graph and this is our g graph. So be careful that you are looking at the correct graph when you're answering these questions. So the first one, we start with f of 2. So we're looking at the f graph over here. The input is 2. Remember, your input is your x, right? So we're going to find where 2 is on the x-axis. It's right here. 2's output is 3. So f of 2 gave me 3. Now the output becomes the second function's input. So now I'm going to find what g of 3 is. Well, remember, g is this graph. So if I go over to g's input of 3, his output is also up here at 3. So my final answer is 3. In the last example, it looks kind of funny. You're using the same graph because they're both f, but it's not going to turn out to be the same number, and you'll see why in a second. So we are taking the input of 0, and we are doing the second f first, even though they're both f. So we're going to find out what f of 0 is. So if we go to the f graph, when the input is 0, the output is 2. So here's why you're not going to get the same answer, even though it's both f, because now my input became 2. So now I'm going to plug 2 into the second function, which is f again, and f of 2 turns out to be 3. So my final answer is 3 again for the second example with the graphs. If you have any questions, you can choose to watch Kirk's video on Unit 2, Lesson 3, or you can see me in class tomorrow. Goodbye.